I'm going to do a little demonstration and illustration activity with aqueous solutions, and the key point is the net ionic equations that you're learning. Please title it Illustration of Reactions in Aqueous Solutions. Our goal is to kind of see what happens when we have this stuff dissolved in water. Okay? It's kind of hard to see sometimes. So first of all, we're going to have a picture. We're going to have a beaker over here. With potassium iodide solution, KiAQ symbol. That'll be one of our reactants.
Is this just in the top or bottom?
Wherever you could put it on the top or bottom. I'm going to have an equation along the top here.
Like, are we going to have a different one?
Yep, you're going to have one on top and one on bottom, two total illustrations. And then over here in the other beaker will be our other reactant, sodium phosphate solution, Na3PO4AQ. And I have the solutions. One of them's in a little squeeze bottle, a clear liquid, and one of them's in a beaker. Okay, I got another clear liquid. These two will be mixing together to see what happens. Okay, so So there's our two reactants. So two compounds in a solution, double replacement. We're going to learn today why double replacement is completely inaccurate. Completely inaccurate. Shall I say incomplete? And now KiAQ. What do these compounds do when they dissolve in water? There was a term we had. Dissociate. It breaks apart. So that's what we're going to show in each beaker here. Here's my water. And so I use a black marker. Have about 4 or 5 potassium ions in there. I'll pass out some crayons if you guys want to use color.
Yeah.
Welcome. And now do me a favor, also have the iodide ions broke apart. 4 or 5. So what we have to picture is when this potassium iodide dissolves, it all breaks apart and you don't see anything. It's all dissolved. And that's going to be the same thing that happens with the sodium and the phosphate here. We're going to have sodium, we're going to have phosphate, and it's all broke apart. So a bunch of sodium ions and a bunch of phosphate ions are there dissolved in our solution. the key point right there. When a compound is soluble, like we said, both these compounds are, it breaks apart, dissociates, and it dissolves. Okay? You can't see anything, it just looks like water. Now let's draw a third beaker here. In between the two, and we're going to picture one solution in each hand pouring it into the middle beaker. So this will get poured in there, this will get poured in there. So we need to predict our products. Got a volunteer that can tell me what K's new partner is going to be. K, potassium and phosphate. Happen to have that formula. Crisscrossing your charges. K3PO4. How about the other new partnership there, Francis?
Would be NAI.
NAI. Now I just need you guys to look at the warm-up and tell me K3PO4, Angel, is that AQ or S, soluble or insoluble? Phosphate's normally insoluble, except it's with what? Group 1. Group 1, good. Yep, AQ. Brianna, how about sodium iodide? Soluble AQ. Okay. So here's the thing. They're both AQ, they're both soluble. So when we're going to draw it in the middle beaker here, everything's broken apart. About 4 or 5 potassium ions there. Some phosphate ions there. Some sodium ions. Last but not least, some iodine. And Griffin, what do we say happens when both my products are soluble? So there's supposed to be no reaction. Exactly right. So what's supposed to happen when I mix these two solutions is nothing. So let's check that out. Clear liquid, are you able to see that clear liquid? You guys see that clear liquid up? Clear liquid. I know, I'm a great actor. I am the man. Alright. And it is on video forever. Alright. So what's supposed to happen if I put some sodium phosphate in here? Still looks clear. Let's put a little more.
It's gonna explode.
Alright. Good, nothing happened. Just like we said. Still clear liquid. Still clear liquid. Other classes I turn the lights off and show it on the overhead, but that won't work with the video camera. Okay. Everyone there, Clear liquid, no reaction. Okay, so
Class of 2016.
there you go. That's 2060 rule. All right, I'm gonna put this here. So before we move on, my last point about this right here, Ki. Is there any actual Ki anywhere in our reactants or our products? Is there any Ki anywhere? No. Na3PO4, no. How about our products? Any of these anywhere in this reaction? They all stayed broken apart. And that's why this right here, that's a waste of time. Completely untrue, inaccurate. That right there, no reaction. Now I want us to see, all that stuff is in here, okay? It just didn't do anything because it stays dissolved. All right, let's do one where I'll spoil the ending. We should see a reaction, okay? And I hope this helps you see it, and I hope it helps you understand the net ionic equation part of it, okay? Not just the reaction part of it. So I'm erasing all this. I'll keep my beaker here.
Are we doing this on the other half?
Yep. So this time I wanted to start out with the same stuff, potassium iodide. That'll be one of my reactants. But this time, I'm going to mix it with something different, silver nitrate. And both of them are aqueous, they'll both be dissolved.
Did you balance the last equation?
I'll take the green.
Why don't you have to worry about balancing that last? There's no reaction, don't waste your time. Yeah, I'm starting out, I'm doing the exact same thing I did last time. I'm going to have my K and my I all dissolved in here. Same thing, a bunch of potassium ions, a bunch of iodide ions, all dissolved. And this is AQ also. So I'm going to have some silver and some nitrate all dissolved. Bless you. Here's my silver. Make sure it's closed.
skills you think?
Maybe it's a little bit more pressure. I
You
guess.
know what doesn't help is acting skills? They're sarcastic.
But I think exactly that was very sarcastic too. So that was a good point.
We see your next
Very
one.
reasonable reaction.
I'll say this, it's much more comfortable for you guys to be here than me in front of the camera by myself. It's awkward being by yourself.
Are you filming right now?
Huh?
Are you still filming?
Yes.
This is gonna be a great video for the rest of the
I'm still in that hall, y'all. I know, but it's just like.
All right. So guys, waiting on eyes. Waiting on eyes. Those of you at home, I'm waiting on your eyes. Eyes, 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 eyes. Okay. So once again, we're going to pretend one in each hand, and we're going to pour them together. First, before I pour them together, let's figure out what it's supposed to be. Who can tell me one of my new partners?
AG and I.
AG and I. And a soluble or insoluble? Thank
Got
you.
the S.
Indicated. Insoluble. All right. Now, how about my other partner? Good. KNO3. So, there's supposed to be a reaction. There's supposed to be a reaction, so I'm gonna let's see if that's true. Alright, so there's my KI.
Isn't the AG&O3 like $200 a bottle?
Huh?
Isn't the AG&O3 like $200 a bottle?
Well, the powder is not this right here. We use the powder to make sure. All right, so there's potassium iodide clear liquid, all right, and I keep it in the frosted bottle for as long as possible before when this eyedropper's broke. So I gotta go here first. Okay, so something's supposed to happen.
Whoa.
It's yellow.
Yellow. And you see on the bottom there? Yeah, so precipitate, one way that I can tell that I had a reaction, and what's the other way? Color change, good. Kind of looks like rotten milk.
Yes.
Yummy.
More rock.
You can see that stuff on the bottom. So there was a definite.
Show your viewers. Your viewers can
I will show the viewers at home.
Oh my God, it's a precipitate.
And what else? And a color change. All right, so for those of you viewing at home, I don't know if you can see the precipitate stuck to the bottom and it changed to a yellow color. No reaction. Reaction. Yeah. Now, let's show this up here.
Now does it burn?
And the big part isn't about, hey guys, need some attention. It's not about showing what's going on in that middle beaker. The net ionic part to me is going to be the most helpful for you. So that's twice.
For those at home keeping score.
Yep, for those of you at home keeping score, I've nailed the side of my leg twice. All right, so let's start here. Silver iodide, it's solid. So silver was blue. I wish I had another color, but and what it does is it kind of floated to the bottom, sunk to the bottom. So I'm going to show it all at the bottom here, and I'm going to circle it because it stayed together as a compound. That's VR. We had a color change and a precipitate, and the silver iodide is now a compound sunk at the bottom of our solution. But here's the thing, also in there, I have potassium and I have nitrate, but because it's AQ, what do we do with it? Break it apart, so let's do that. Get that down, and I'm going to pause while you get that down so we can talk. Need time to do a little karate kick action here.
Woo!
For those of you at home.
That was good.
Alright, so,
Benson for crazy pencil.
Okay, guys, I see.
alright, now I'm going to wait for eyes. I don't want anybody to be writing. I just want to talk for a second. Make a couple different points. Okay. So first of all, these ions right here, they're there, floating around, not doing anything. There was a term we had for them. Anybody remember that term?
Dissolved.
Nope. No, we're on the wrong track. Not dissociation. They are there. They did not take part in the reaction. I heard it.
Oh, the, something.
Spectators. Sorry, I didn't hear. It was too quiet. Spectators. Here's our spectators. Right. So, spectators didn't take part. Do me a favor. You don't have to do this, but just they didn't take part in the reaction. So honestly, I'm gonna cross them out because we said they didn't take part. And because they didn't take part here, they really weren't important over here in the reactants. I'm gonna cross them out over here too. And I want you to take a look at what I didn't cross out. I have negative iodide ions. I have positive silver ions. I have a compound, silver iodide. What state of matter would this be here?
Solid.
Solid. I actually have my net ionic equation. The only stuff that took part in the reaction when I mixed my two solutions together to get this. And if you want to write the iodide ions first, you can. It's not wrong, but I usually write the positive metal first. Okay. Positive silver. It's dissolved in a solution, so you have to put AQ. That's important. We got this right here. My iodide right there. Okay. Also dissolved in a solution. In that form, AgI, and you guys were exactly right, the state of matter. Solid. There's my net ionic equation.